Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. In this snippet, taken from our earlier conversation, Jeff Welser, Vice President in IBM Research, discusses his view on the future of nanotechnology. So, looking forward, where do you think nanotechnology is going to have the most significant impact?
I think, at least in the semiconductor world, the thing we're looking at now is what other types of devices should we be creating as the digital silicon transistor does slow down in terms of its scaling. And I think we now have new opportunities with things like artificial intelligence or deep learning networks. We're looking at designing chips that would run those kinds of algorithms much more directly. The architecture we use for normal computing chips, von Neumann architecture, is great for high speed, very high precision floating point calculations. That's not what you need for AI. That's not the way the brain works, for sure. So how do you actually design a chip that could do that more efficiently? So we're looking at things like a resistive memory / transistor style device that would rely on material changes at the nanoscale to actually look more like a neuron, perhaps, or in terms of its connectivity or the way it learns information. Certainly, I think we'll find other places. We move into quantum computing, which has a whole new set of challenges for the types of systems we want to build, operating at very, very low temperatures, and potentially having kinds of interference from defects or from other manufacturing errors that cause decoherence that we never had to think about in the electronics world when we weren't worrying about maintaining quantum states.